Right, so good morning, everyone, again, formally, and we are starting off with chapter 5, time value of money. And to begin with, folks, I'm going to give you two choices. Let's start simple. You have two choices. Um, so let's write down those two choices, easy ones. One is if you were getting an option to receive $1,000, let's say, one choice is to receive that $1,000 now. And the second choice, ladies and gents, is to receive the same $1,000 on the same date next year. Which one would you go for? Which choice do you think is more valuable for you?
The one today?
The one today looks like a better choice. Why do you feel that way? What is
Be-
so different between today and tomorrow? Because the amount is the same.
No, they're not the same. I think the value of money goes down over time or something like that. Like,
Yes, that is right. Because even if we don't talk about value of money per se to begin with, we can just imagine the fact that if we were to receive our $1,000 today, then we could put it in a bank account and it would earn some interest over the course of the year, which would not be possible if you received $1,000 on the same date next year because you would have lost 1 year, 1 full years of interest income, or you could have done anything with the $1,000 received at this point in time right now. So it's a valuable choice. Asif is saying in the chat box, next year the value of money depreciates, which is kind of okay to say because we live in inflationary regimes, and the purchasing power of money declines over time. So any money received today, a dollar received today is more valuable than a dollar received tomorrow, right? So that is what is the premise of the whole concept of time value of money. So as we go further in the discussion on time value of money, we will need to deal with some key uh, time value variables. So let me just give a little acronym to this time value of money so that I don't have to say it in its full form all the time. I'm just going to write it as TVM. So key variables in TVM. Let's first make a note of something known as the present value, which is the value of money at the present moment. We will write this as PV. And ladies and gents, as we talk about this, I wanted to also ask you one question. Have you been able to get hold of a financial calculator? Because it will be a very handy tool from this chapter onwards. So the sooner you have it, or maybe you have an app on your phone, that will be good enough. Okay, Crystal, you got yours, which is good. Um, right. So present value, if we were to give a definition to it, a working definition, we could say that present value is the current dollar value of a future amount. We will put it in action shortly and see current dollar value of a future amount. It's enough to remember this at this point in time. This future amount we will call the future value and denote it by writing FV, future value. So this is one important variable in time value of money. As far as the calculation part is concerned, ladies and gentlemen, whenever we are faced with a situation when we are supposed to compute present value of a future amount, the process that is followed is known as discounting process. Discounting process. And for the purpose of discounting, we will need a rate of discount. So we will call it discount rate, right? Discount rate. Discount rate has other names as well. In many places, you will see the discount rate being referred to as the required rate of return. The name will change depending on the context. So discount rate is also at times called the required rate of return. And at other points, it's called the expected rate of return. And yet at other points in time, it's referred to as the cost of capital. So when you go through the chapter on capital budgeting and cost of capital, you will realize that the same thing that we will use here in the form of a discount rate will be known as the cost of capital there. Right. Let me just quickly add a page, or maybe 2 pages, 3 pages. Right. So here we are. We have been talking about the introduction to time value of money. We have said thus far that money has time value and that a dollar received today is more valuable than a dollar received tomorrow. And in time value of money, we are now listing the key variables that we are going to come across. So we are not really going into the explanation of these things. We are just looking at a listing for now. The first item that we've listed is the present value, which will simply mean the current dollar value of a future amount. And computation of the present value will require us to do some discounting, for which purpose we will need a discount rate. And the fact that discount rate is known by its alternative names as well. Then the second item, the second key variable, just like we have present value, we will have a future value item. We will call it FV. And just like we defined the present value.
Everyone. So 1 minute, please, and now come in. Could you just please scroll back down? Let me get the information, please, quickly, and you'll scroll back up. Thank you.
Okay.
Thank you, sir. That's good.
Okay, thanks, Masli. Right, so just like we defined the present value as the current dollar value of a future amount, we can apply a reverse definition to the future value. We can say that it is the future dollar value. Future, this is U, by the way, future dollar value of the current amount. So that, for example, if you ask a question, if I have $100 today, and if I invest that money for 1 year at a rate of 10%, then what are you actually saying? So if we convert this statement, if we represent this statement in terms of the listing that we have seen thus far, we will say as follows. Let us write down this thing. So if I have $100 with me today, $100 today, and the fact that I'm going to invest it for 1 year at a rate of 10%, at a rate of 10%. And I ask a question, what is the amount of money that I will have after 1 year? And we will know that we will have $110 after a year. So in time value variable terms, this $100 today is the present value, and the future value of $100 today is 110. And if somebody were to say the opposite, that I will give you a sum of $110 after a year, then you would want to know its current worth, that if I receive $110 after 1 year, what will be its purchasing power after a year in today's terms. And then if you said that the purchasing power of this $110 received after 1 year would be just $100 in today's terms, then you would be saying that the present value of a $110 received after 1 year is only $100, right? So that's how we can frame our expressions. At any point in time, if you lose track of what is being said, you will please interrupt and ask me. So just like computation of the present value involved using the process of discounting, calculation of the future value will use the process of compounding process, right? So for which purpose, just like for calculating present value, we needed a rate and we called it the discount rate. For calculating future value, we will need a compounding rate, also known as the growth rate. At what rate the money will grow over a period of time. That's what is being said here. Then, in the example that we just took, so this, if we looked at it in the form of a timeline like this, that this is time zero, where I have a sum of $100, and this is the end of time one year, and here I have $110. So this is my present value. This is my future value. This whole length of time, we will give a name N, and we will call it N number of periods. So N will be the time. This is the third key time value variable, N, number of periods. Sorry, misspelled it. Number of periods. Note that I haven't said number of years, because the definition of a period could be either a month, or it could be a quarter, or it could be a semi-annual period. Or if in case we are talking about an annual period, then we will say number of years. So it depends how we are defining the length of time. The fourth thing that is pretty obvious from this example that we have considered is that if the present value that we are, let us say, investing somewhere is $100, and by the end of 1 year, it becomes $110. So in this case, N is equal to 1 year. The fact that 100 changes into 110, so it must have grown by a rate. And we know just by visual inspection in this case that the rate is 10%. It grew by 10%. So that's the fourth key variable. We will call it R. You can call it I if you want to call it interest rate. That's up to you. This R or this I or A or B or C, whatever name you want to give to it, is basically the rate, which can either be used depending on the context for discounting purposes, or depending on what you're doing, compounding purposes. And another variable, the fifth one, we will give it a short name, PMT, and we will talk about it a little bit later. We will not introduce this thing into our analysis at the moment. We will wait a few minutes. I'm just going to give you the full form of it. It's going to be called payment. So whenever we write PMT, it means payment. So there are 5 time value variables. If you were to write them down quickly, you would say, or let me show them to you on the calculator itself. See, you will be able to identify. Are you all able to see my calculator screen?
Yes, sir.
So focus on the third row of buttons. What do you see? You see N, which stands for number of time periods. Then you see the next item is I over Y. It stands for whatever we wrote as R, the rate. That is what it means on the calculator. It stands for interest per year, right? Then the next item that you see is PV. It stands for present value. Next item that you see is PMT. That stands for payment. And the final item that you see in this row is FV, which stands for future value. So there are 5 time value variables. And if you want to compute one of them, the other 4 will have to be known, right? So if we know 4 out of these 5, we can calculate the 5th one. Right. Let's learn a little bit more about the type of cash flows we can encounter, and then what type of formulae can be used for dealing with those type of cash flows. we can come across, ladies and gentlemen, let's just make a heading here, type of cash flow patterns first. There can be three possibilities. We could have a cash flow which is of the nature of a single sum. We can also call it a lump sum. One payment at a given point in time, that is all. I am going to pay you $1,000 after 3 months, and that is all there is to it. So it's a single sum of $1,000 happening after 3 months. So if that is the kind of situation we are in, we will call it a single sum. Or just the example that we took here above here, where we said we have $100 here to invest for a period of 1 year at a rate of 10%. This is a single sum or a lump sum. A lump sum of $100 invested for a year at a rate of 10% ends up in being 110 after 1 year. The second possibility is that we have an annuity at hand. So what is an annuity then? So let's quickly define what's an annuity. It is a series of cash flows, number one. But the fact that it is a series doesn't really make it an annuity. It has some other distinguishing features. This series of cash flows that we are dealing with should have these two features for it to be called an annuity. What two features? Number one, that the cash flows occurring in the series at various points in time should be equally spaced in time. Like, for example, every day, every week, every month. So the time interval between the cash flows should be the same, equally spaced in time. Not only that, the amount of the cash flow should be equal amounts. So, for example, if I'm living in a rented accommodation and if I'm paying my landlord a rent of $5,000 every month, then it's an annuity. I'm paying the annuity. The landlord is receiving the annuity because the payment is being repeated every month. So it is satisfying this criteria every month, equally spaced in time. And since the payment is of the same amount, $5,000 every month, therefore it is satisfying the second criteria as well. So it becomes an annuity of payments. Within annuities, ladies and gents, there can be two types of annuities. What two types? Number one, an ordinary annuity. Ordinary annuity is also known by the name of a deferred annuity. Deferred annuity. And it is an annuity where the payments or the cash flows are occurring at the end of the time period. So in the example that we were talking about, if I was paying the rent to my landlord at the end of each month, we would say that we are talking about an ordinary annuity, end of the time period, end of a period. So if I'm paying my $5,000 at the end of each month, we have an ordinary annuity at hand. On the other hand, if I'm paying my rent at the beginning, at the top of each month, then we are talking about an annuity due. So in which the cash flow happens at the beginning of a period. Right? And the amount which I'm referring to here, in this example, I'm talking about $5,000 as rent. So this equal amount that we talk about in the annuity is if I change color here, is this equal amount, if I trace it back to what we were talking about, it is this equal amount which is called the payment, which is the fifth time value of money variable. So whenever you are dealing with payment as an item in your computation, you know that you're dealing with an annuity. Which type of annuity? will be told to you by the fact whether the cash flow is happening at the end of the period or the beginning of the period. And accordingly, you will decide whether you're dealing with an ordinary annuity or an annuity due. Right. Then the third type of cash flow, we have listed two types. This was number one, single sum or lump sum. This is number two, an annuity. And then we have number three, which we will call a mixed stream of cash flows. Mixed stream, or some people also call it an uneven stream of cash flows. Right? So a mixed stream will be cash flows will be repeated at random intervals of time, and they may or may not be of equal amounts. So these two criteria, this one and this one, need not be satisfied for a cash flow stream to be called a mixed stream. That's why the name, mixed or uneven. So the cash flows will be repeated, of course, otherwise it will not be a stream. It will be a single sum only. So cash flows will be repeated over time, but the time interval between each successive cash flow may vary, and the amounts may also be different.
So excuse, please, could you just scroll up a little for me, please?
How far up?
Look, right, a little more, right? A little more. Right, yes, so thank you. You could go ahead. Thanks.
Okay. All right. So what are the two? Yes, Avalon.
I just wanted to ask a question with respect to the annuity payment, right? You're paying it at a certain period every year. But for a continuous period until like the end of the year, right?
For as long as you wanted to
For
pay.
as long, huh?
Yeah. Yes.
For as long as what?
For as long as, so if I'm going to live in my house for 5 years, and if I keep paying my landlord till that amount of time, it is a 5-year annuity. Or
Right.
even banks and financial institutions allow us to invest in long-term annuities. So I keep making recurring deposits into the annuity for, say, next 5 years or 10 years, and after which the policy will mature and give me a lump sum back. So annuities can be as short as possible. I mean, as short as 2 months, 3 months, 4 months, and as long as maybe 10 years, 15 years.
Right.
It's interesting, Avalon, that you asked this, because if you take an annuity too long, and I'm going to write this as a special case here by changing my color here. So I'm writing it with an asterisk. I'm saying that an annuity, whether it's an ordinary annuity or an annuity due, whichever, an annuity which lasts forever. Avalon, think about that.
Mm.
Lasts forever. So I'm saying an infinite annuity is called I'm writing it in capital letters, a perpetuity. That can also happen. Well, realistically speaking, nothing lasts forever. But when we say lasts forever or for an infinite period of time, we actually basically are meaning indefinitely. So for a very, very long period of time. So a good example of a perpetuity is, an endowment fund, which the university and other institutions create. Right? How much money I should have in my endowment fund as a university, for example, so that I can sustain a certain amount of scholarship every year to these many students for an indefinite period of time, because the university will keep running, and I should have enough money in the endowment fund, which will be able to fund a certain amount of scholarship to a certain number of students for as long as the university exists. So who knows how long will the university exist? So it's a case where we use a perpetuity or an indefinite annuity. You get my point, Avalon?
I understand, sir.
Okay, great. So thank you for that question. So it allowed me to go into what is a perpetuity. Right. So because if I had not mentioned this, I mean, I would have eventually at some place, but it's good that while we are talking about the annuity, we talk about this special case as well. Right. So as far as the computations involved in this chapter in time value of money, so I'm just writing calculation methods. And for calculation methods, you have various choices. Number one is use the formula. Foolproof way to get your answers in all sorts of situations, whether you have the calculator, you don't have the calculator, the battery is in the calculator is low, it is dead, it fell, it broke down, somebody stole it, no problem. If you know the formula, you can go ahead. Even with a normal scientific calculator, that will be okay. The second way is to use time value tables. So I'm just writing TVM tables. I have to look for them today to show them to you. So maybe at some point I will be silent for a few moments because I'll be then looking for TVM tables on my computer somewhere to share with you. And the third and the easiest way is to use the financial calculator, of course. All three methods are permissible to be used in an examination situation. Right. And as far as possible, I will try to go over with you all three methods at various points in time. But I strongly suggest that we go ahead with this. It not only increases our speed of progress, but also makes life easier. For now, however, what I'm going to do is going to give you an opening list of formulae that can be used at your convenience. So we will live with the type of cash flows that we had mentioned. The first type of cash flow that we had come across was a single amount. And if we are dealing with a single amount, and within the single amount, if we want to calculate the future value of a single amount, we will write as follows. FV, future value, will always be equal to the present value multiplied by 1 plus the rate raised to the power of n. So it's a simple enough formula. This is a school day formula, compounding formula, basically, that you're finding the ending amount, which is the future value, on the basis of the fact that this is the amount that we invested today at this rate for this period of time. So the ending amount would be this future value at a future point in time. What is also important for you to note from here is that this item here, 1 plus r to the power of n. So let me write here where 1 plus r to the power of n is called the future. I'm just writing the acronym, but I'm saying the full words. Future value interest factor of $1 at a rate called R% for n periods. Right. So let us calculate this. Let's say we have $1 at the moment and we want to calculate its future value. What will we say? We will say future value is equal to, we have $1 at the moment with us. So 1 multiplied by 1 plus, let's imagine a rate of interest, 10%. 10% for one. So let's say n is one period. So we have 1 plus 0.10 is equal to 1.10. So we will say that 1.10 is the future value interest factor of $1. Which $1? This $1 at R%. R is in this case 10% here, at 10% for n periods, for one period in this case. Right. Now give me a moment and let me look for the time value tables so that we could look at them side by side. So I'll be quiet for a few moments till I look for the thing. TVM tables. TVM tables. Right. So can you see my screen on which I've put up some tables?
Yes, sir.
So I am referring you to where is the future value? Right here. So I'm asking you to pay attention to this part. Table A2, look at the heading of the table first. It says future value interest factor of $1. Oh, this is the annuity table, sorry, wrong one. This one, future value or interest factor of $1 compounded at K%. So this table uses the letter K for interest rate instead of R, so that doesn't make a difference to us. So future value interest factor of $1 compounded at R% or K% for N period. So it's written like this, FVIF. And in the subscript, we are writing the rate and the time. And then we are writing the formula 1 plus K to the power of N or 1 plus R to the power of N, right? So what we did just now on the writing pad, we were calculating the future value of $1 at the rate of 10% for 1 year. So if you look at the table, and if I can annotate this a little bit. We have this one period here, right? One period here. And the rate of interest that is of interest to us is 10%. So I'm going in these columns, 10% is my interest rate. And for one period, if I read the value, you see 1.10, that's what we had calculated. Do you recall that? So this 1.10 was a result of this calculation. So we had done this, FV is equal to PV times 1 plus. So if you want to write K instead of R to the power of N. So we had said, if I have $1 at the moment, which is this $1, and I invest it at 1 plus the 10% rate, which is this 10%. So I write it as 0.10 raised to the power of N, which is, I'm interested in one time period only. 1. So notice that it will take you to 1.10, which is this value. So if you don't want to remember this, then you can just look up the value in the table and then you can just answer. So if I'm asking you, if you have $100 to invest, at the rate of 10% for 1 year, what will be your ending amount? So I'm asking you basically to calculate the future value, and you will say, I have $100, that's my present value, and I need to multiply this by 1 plus R to the power of N, right? So we can calculate manually. We can say 1 plus 0.10 to the power of 1. So that's $110. I could also have written this as FV is equal to PV multiplied by, because I know this 1 plus R to the power of N is nothing but the future value interest factor, this thing. I could just write here future value interest factor at R% for N periods. And then I could just plug in $100 is my present value. Future value interest factor at 10% for one period is 1.10. I look it up from the table and just calculate like that. It's easy, right? Any questions, ladies and gents, thus far?
No, sir.
Okay. On your financial calculator, if you have to carry out the same operation, first of all,
So a quick question.
Yes, please.
So you recall saying like one period is 1 year, but in an instance is 6 months. or will we treat with that? Or
Yes,
two
we
years?
will deal with that at an appropriate time.
Okay, thanks.
Right. So first of all, let's put your calculator to be used. Let's prepare it for use for the first time. So all of you who have the calculator, please follow my voice prompt and take the steps which I'm taking on the screen. First of all, I want the calculator to be set to display 4 places after the decimal so that we have a little bit accurate results. So I'm saying press second function, this yellow button, and then come down at the bottom to the last row where it says, where you have a decimal. At the top of it is written format. Press that. Right. So second function, format. Your display should change to DEC is equal to 2. DEC stands for decimal places. So at the moment it is set equal to 2. I want to make it 4. So I'm going to press 4. So keep watching my cursor here. 4 is what I'm pressing. And then I'll go to the top row of keys and press the enter button to save my input. Enter. Once I do that, the display should say DEC is equal to 4. Then I can come down and clear my display. You'll have to press the clear button twice. So now you will come back to 0.0000. That's the first thing that you need to make sure. The second setting that I want you to do is about the payment per year. So you see here, this second time value key is saying interest per year, I over Y. At the top of it in the yellow font, it's written P over Y, that's payment per year, right? So anytime we use the second function, because the second function is a yellow key, so anytime we press the second function, we are using these yellow commands written here. So I'm going to press second function, and I'm going to press this, which is basically that I want to deal with the payment per year. In my calculator, you see payment per year is equal to 1. Make sure that in your calculator also it is set equal to 1. If it is not, do that by pressing 1 and then pressing enter. So for example, in some calculators, what happens is that when you take them out for first use, the payment per year is set to 12, like this. So if that is the case, many times it will happen that you will get errors in your computation. So if it is set to 12, the way to take it back to 1 is that you will press 1, follow my cursor here, press 1, and then press enter, and then clear the display. And recheck second function, again, payment per year. Now it's set to 1, so everything is okay. Also make sure the third thing is that on your display panel on the calculator, you should not be seeing this. You should not be seeing this item, which you see here, BGN. It stands for begin. It should not be on display. If it is, then you have to make it go away, right? So to make it go away, so let's say your calculator looks like this and BGN is being displayed. What you will need to do is press the second function again and come here to the payment button. At the top of it, you see it's written BGN. So press the payment button here and then press the second function again and press set, and you see, press this enter key on the top of which is written set. So you see the BGN has gone away and we are now set to the end period. And then we will clear the display like this. That's it. So now your calculator is good to go. So the item that we were doing, we were saying that we are investing $100 for 1 year at a rate of 10%. So what is the amount that we will have after 1 year? So which means that $100 we have with us at the moment. So that is the present value. We have the rate of interest R, we know that is 10%. We know that the time period involved is 1 year. And we want to know the future amount, the future value after 1 year. So we want to solve for future value. Before we begin to input our items into the calculator, please remember one thing, and let me write that here. Let me annotate it and write it here so that there will be no scope for a mistake. Let's write that in red so that it stands out. Whenever you feel that the cash is leaving your pocket or purse, all cash outflows should be entered into the calculator as negative numbers. And obviously the opposite is true, all cash inflows. If you feel that something is coming into your pocket or into your purse, all cash inflows must be entered as positive numbers, right? Otherwise, again, you will start seeing error messages on your calculator. So let's go back to the calculator here and see an example of how this will happen. Now, I have $100 today, and I'm saying that I'm going to put it in a bank or maybe invest it somewhere. So at the moment, $100, I'm saying, let me close this annotation thing. At the moment, I'm saying 100, I'm entering onto the calculator, and I'm saying this $100 at the moment will leave my pocket because I won't get to use it because I'm going to invest it somewhere. So because it's going to leave my pocket, I'm going to press this button where my cursor is hovering and change the sign of it. I'll make it negative. And once I have this minus 100 on display, I will store it in the present value button. This is the present value. Then I know the time period for which I'm investing is 1. So I'm going to press 1 and store it into the N button. Right? So you will keep on seeing on display that it's happening N is equal to 1. Then I'm saying that 10% is my rate. So I'm pressing 10 and storing it into the interest rate per year here. So I over Y is 10%, right? There is no other payment that I'm going to receive in between. So I invest my money, $100 today, and after the completion of 1 year, I'm going to receive an amount which will be the future value. In between, I will receive no other payment because realize the fact that in this example, we are dealing with what type of cash flow pattern we are dealing with. A single cash flow of $100 being invested. So we are not talking about an annuity here. It's not a series of payments or series of cash flows that are happening. So the issue of payment will not arise anyway. So we will just say 0 is our payment. And then we will go here at the top where you see CPT is written. CPT stands for compute. So we press compute and we say compute what? Future value. So you will see 110 as your result. So without knowing any formulae or without using any tables, you could just enter the values properly onto the calculator and get your result. So once you get a hang of it, it's very quick and simple. Right. Now, after you've gotten the answer, you will clear the display. So see where my cursor is. So if you clear the display becomes 0, but it doesn't mean that the values which you had stored into the time value buttons here in these 5 of them, they have not gone away. They are still here. So anytime you will embark on a new calculation, if you do not clear the memory of these time value variables, then again, you will start getting errors. So make it a habit if you're going to use the calculator that after each time value calculation is completed and you have gotten the result that you want and noted it down, then press the second function again and go here, the future value button. Just see what is written at the top of it, CLR TVM, clear TVM. That's what it means. So press that, right? So you will see nothing happening visually on this on the display of your calculator, but internally it has brought the memory of all these variables back to 0, and you're ready for a fresh calculation. Right. So we are dealing with we dealt with a single amount, and we dealt with calculating the present value of that single amount. Future value of that amount. If you were to calculate the present value, what would you do? You would just play around with this equation, right? You would write it in present value terms. You will say PV is equal to FV divided over 1 plus R to the power of N. Alternatively, you could also write this as FV multiplied by 1 over 1 plus R, power of N, right? Where 1 over 1 plus R to the power of N is called the present value interest factor of $1 at R% for N periods. Right? You will interrupt and ask, please, if there is an issue somewhere. Right. So if we had to do the reverse of the calculation that we just did, so let's say the question was the question was that at the end of 1 year you are going to receive $110, right? Or let's first of all explain the PVIF, right? So let me erase this for the time being. So what does it mean? So what it means, this PVIF, or this 1 over 1 plus R over N, means what? That if, let us say, time period is 1 and the rate is 10%, and I receive $1 after 1 year, and the money has been losing value at the rate of 10%, let's say, then what will be the purchasing power of this $1 received after 1 year, right? So let's check. Present value of the $1 received after 1 year is going to be equal to 1 over 1 plus 0.1 raised to the power of 1. So that's equal to 1 over 1.10. 1 over 1.10 gives us what? 1 divided by 1.1. 0.9091. So the purchasing power of this $1 is about 91 cents after 1 year if money loses value at a rate of 10% per year. I hope everyone understands what I'm telling you. So if you were to look at the tables, now, so you will go into a table which talks about present value interest factors. So let us see where that table is. Table A1 is future value interest factor, not interested. Table A2 also talks about future value interest factors, not interested. Table A3 talks about present value interest factor of $1. That's what we are interested in. Because you will see both the future value tables and the present value tables, both of them. So let's open the annotation panel and see. We'll talk about this. This is, see here, $1. And there is another table pertaining to present value. There's another table pertaining to present value, which if I scroll, you will see, again, this is a present value table, but this time it's not a $1, it's a $1 annuity. See that? So these two things are different. $1 means there is only one single dollar happening at a certain point in time. A $1 annuity means there is a series of $1 being repeated over periods of time. I hope you're getting the difference. $1, $1, another $1, another $1. If that is what is happening, then we are talking about an annuity. And if we are talking about just $1 alone at a particular point in time, and that is all there is to it, then we don't go to the annuity table. We go to only the $1 table, which in this case is here. So what was our what were we trying to do? We were saying that if money is losing value at a rate of 10% each period, then after one period, if I read the value corresponding, the purchasing power of this $1, it will be just worth about 91 cents, this value. That's what we had calculated. So you could just calculate here. You could just write here present value is equal to I'm going to receive $100 after 1 year. And because it's losing value at a rate of 10%, now see, I'm calculating present value. So I'm going to ask you a conceptual question. If I had to give a name to this 10%, what would I call it? Do you recall what is this rate called in the context of calculating the present value?
Discount rate.
Yes, Asif, thank you. That's correct. This 10% is the discount rate. We are calling it discount rate because we are calculating the present value. The same 10% when we were calculating the future value, the name would change to the compounding rate or the growth rate. Right? So we are, or we could have written it this way also. Right? And we would have obtained the answer. It would have been $90.91. $90.91. Or we could have said present value is equal to future value multiplied by the present value interest factor of $1 at R% for n periods. And we would just substitute the values. Future value is 100 because that is what we will receive after a year. And the present value interest factor of R%, which is this 10% for n periods, which is this 1 period, is 0.9091. So we'll just read off from the table and put it here. And that will give you the same result, 90.91. If you were to do the same thing on your calculator, it would be simple enough. Let me just clear the display. And sorry. Right. So I'm saying that I'm going to receive $100. So I'm going to receive $100. Ladies and gents, receiving something means cash coming into the pocket. So $100 plus when I'm going to receive it after 1 year. So that's a future point in time. So I will store this into my future value. I will receive it after 1 year. So 1 is my time period during which the rate of discount is 10%. So 10 is my interest per year. And between now and the next 1 year, there is no other payment because it's not an annuity. So 0 is my payment. And then I say compute CPT present value. So it gives me 90.91 and 90.9091. And you see that there's a negative sign before that. This negative sign, don't let this make you believe that this is negative money. Well, because money cannot be negative. This negative sign simply tells you that in the present moment, you must be giving up $90.91 so that in the future, you will have $100 in your pocket. $100 came into your pocket after 1 year. That was with a positive sign because maybe you decided to invest $90.91 at the top of the year. So during this 1 year, it grew into $100. So one of these signs will be negative. So it could work out the other way around as well. So let's just observe I'm clearing the display, and then I'm clearing also the time value memory by pressing second function and clear TVM. And then I'm saying that I'm going to pay $100, pay $100, because I'm going to pay $100 after 1 year. So this money will leave my pocket after 1 year. So I'm going to put it with a negative sign. So this $100 negative going out of my pocket after 1 year's future value. 1 is my time period, and during which time the rate is 10%. And compute present value. This time you see the present value has occurred with a positive sign because I stored $100 future value as a negative sign. So it simply reflects a position where maybe I may have taken a loan of $90.91 from you today. So which meant that You might have given $90 to me today, so that money came into my pocket today. When I return those $90 along with interest of 10% to you after a year, I would pay you back $100, at which time $100 would leave my pocket and therefore carry a negative sign. Right, so I'm going to clear the display, and then I will not forget to clear the time value memory by pressing the second function and clear TVM. So that now calculator is ready for next computation. Right, so we have seen with the case of a single amount how to calculate the future value and the present value, both with the help of the formulae and with the help of time value tables and with also the help of a calculator. Let us proceed further and talk about annuities. So this was, if this was A, single amount, then B would be annuities. B is an annuity. But within annuities, you know that there will be two cases. One where we have an annuity, ordinary annuity. So let's call it case one, ordinary annuity. Now, annuity we know is a series of equally spaced payments of equal amounts. So in this case, I'm using the word payment. So PMT will have a role to play. So in this case, if I have to find out the future value, let us say, of an ordinary annuity. So I'm going to write future value of an ordinary annuity is going to be equal to the payment multiplied by what did we do when we were dealing with $1? Didn't we say multiplied by the future value interest factor of $1 at R% for n time periods? So if I leave it like this, FVIF, this will become incorrect because it will take me to an incorrect table. It will take me to the future value interest factor of $1 table. I don't want to go there because it is not the $1 that I'm thinking about. I'm thinking about an annuity of $1, right? So the table that I should go is future value interest factor of an annuity of $1, right? So this will be the formula. If you don't want to use time value tables, then you can just write the formula for this guy here, which I'll put it in the next line for you. Future value is equal to, so for doing this part, you will need access to a time value table. But if you only have a scientific calculator, you can do this. Payment multiplied by, now I will write the definition of FVIFA for you. It will be equal to 1 plus the rate to the power of n, and we will subtract 1 from it, and then we will divide this whole thing by the rate. This thing is FVIFA, right? So as we go along, let's complete the formulae part. As we go along, we will pick up examples slowly, and we will see the application of all of these, as well as using the calculator. If you wanted to calculate the present value of an annuity, you would say PMT multiplied by this time the present value interest factor of an annuity of $1 at R% for n periods. Very, very simple. And if you did not have access to time value tables, and if you did not want to use the financial calculator, you just wanted to rely on the grassroots formula, you could just use the definition of PVIFA, which would be, let me give myself some space, which would be that PV will be equal to payment multiplied by, we will write the definition for PVIFA, which will be 1 minus. So you see, it's the reverse of what we wrote for FVIFA. So in FVIFA, we subtracted 1 from something. Now it is from 1 that we are going to subtract something, 1 minus. Here we wrote 1 plus R to the power of n. Here we will write its reciprocal, 1 over 1 plus R to the power of n. and then divide the whole thing by the rate. So this becomes the present value interest factor of the annuity. Right? If you're dealing with annuity due, where the cash flow occurs at the beginning of the time period, you don't have to do much really. In this case, if you want to calculate the future value, you will follow exactly the same method as you were following with the ordinary annuity. So for example, we will just use this method and calculate the FV of the ordinary annuity and write it here, FV of the ordinary annuity. And just multiply this by 1 plus R, that's all. And if we were calculating the present value, we will do the same thing as we did before. We will use this or this to calculate the present value of the ordinary annuity. Ordinary annuity. And then when we're done with that, we will just multiply the result with 1 plus R. That's all. So dealing with annuity due is pretty much the same as dealing with the ordinary annuity. It is just that you should not forget to multiply the result by an additional 1 plus R factor. That's all. The third type of cash flow pattern that we had identified, and let's write that as mixed stream, or an uneven stream of cash flows. In this case, there are no new formulae to learn. So let us say a mixed stream is like this. So here we have time, right? So let's say 1, 2, 3, 4. And here we have an amounts column. So if I wrote the amounts as 50, 50, 50, 50, this becomes an annuity because it's equally spaced and equal amounts. But if I write the column as this, 30, 10, 20, 40. One of the criteria for an annuity is not satisfied. I know that these cash flows are equally separated by periods, but they are not of equal amounts. So therefore, it is a mixed stream. So if that is the case, and if I want to find the future value, what I will do, I will treat this first item as a single amount and multiply this by FVIF and calculate its future value. Then I will treat this as a single amount, multiply this by FVIF and calculate its future value. I will treat this item as a single amount, calculate its future value and put it here. And like that, I will treat all items in the series as single amounts and calculate their future values, at the end of which I will add them up to get the total future value of the whole stream. And if it was the present value, instead of calculating future values, I would calculate the present values, individual present values, present value of this, as treating this as a single amount, present value of this item, treating this as a single amount, then treat this as a single amount, present value again, treat this as a single amount, present value of this again. When all present values are available, just add them up to get the present value of the total stream of cash flows. That is what we will do. How to do this? Well, if you look at the formula and if you know the use of time value tables, you will know what to do because you've seen a short example of that. But if you want to use the financial calculator, there are a couple of ways that in which this can be done. When we pick up a problem, I will demonstrate those ways to you. So for now, ladies and gentlemen, I've given you a backdrop of what time value of money is. I've told you what key time value variables are. You know that there are 5 time value variables: time period, rate of interest, or rate of discount, or rate of compounding, call it whatever you want it, depending on the context. Then we have the present value, then we have the payment, then we have the future value, right? So 5 time value variables are there. And then we have identified the type of cash flow patterns. We have said that either we could be dealing with a single sum of money, which we can call a lump sum also, or we could be dealing with an annuity, which could be either an ordinary annuity or annuity or a deferred annuity in which the cash flows will happen at the end of a time period, or it could be an annuity due where cash flows would happen at the beginning of the time period. And if an annuity were to go on indefinitely for an infinite period of times, we would call it a perpetuity. Um, Ladies and gentlemen, and then we talked about mixed streams where the cash flows will not have any definite pattern in terms of them being spaced out over time, and also in terms of their amounts. They will be unequal and random. And then we have seen the various formulae that can be applied to calculate the present value and the future value of a single sum of money. We have seen the formulae for calculating the present value and future value of annuities, whether they be ordinary or defer or due. And we have seen how to calculate the present and future values of a mixed stream of cash flows. The only thing, and I will again change the color here to this, we have not dealt with how to calculate the future value and present value of a perpetuity. Ladies and gentlemen, do you remember what is a perpetuity? Anyone remembers what is a perpetuity?
Infinite
Payments
annuity.
that going for like a ongoing period of time that's not definite at all.
That's right. A perpetuity is an infinite annuity. That's all. An annuity which goes on forever is a perpetuity. Right. So if you think about perpetuity for a moment, just close your eyes and think about it for a moment, you will realize that since a perpetuity is going on for an indefinite period of time and there is no particular end point, thinking about future value of such a stream of cash flows is absurd because the time period is simply not ending. At for which point of time you should calculate the future value? Future value at what point in time? That's not defined. So this is not possible. Calculating the present value of a perpetuity is possible. So let's say if you look at it in a timeline format, so $1,000, $1,000, $1,000, $1,000, and it goes on the far distant future, which you can't have a look at. And these are time periods, 1, 2, 3, 4, and that going on. And this is time zero. So let us say if somebody says, hey, look, I'm giving you a deal. I will pay you at the end of each time period, a sum of $1,000. This is a scheme I'm running, which if you subscribe to, if you invest your money today into this scheme, which will keep on paying you $1,000 at the end of each period, till for the foreseeable future and beyond, then the question is, how much should you invest in such a scheme today? So since the question is how much should you invest in it today, today is time zero. So basically the question is you're trying to find out the present value of this whole stream of cash flows, which extends into an indefinite future. So if I have to calculate the present value, that will tell me that the worth of this whole thing that extends into the future is some dollars at this point in time. How much? How much should I pay? What would be the fair price to pay for this today? So I will calculate present value simply as the cash amount that is being paid here, which I'll write as payment because it's being repeated across equal time intervals and it's the same amount that's being repeated. And I'll simply divide this by R. That's all. So if my R was 10%, a reasonable price to pay for this today would be 1,000 divided by 0.10. Right. So 1,000 divided by 0.1 would give me $10,000. So if I invest $10,000 today in this scheme, the scheme promises to keep paying me $1,000 at the end of each period till foreseeable future. That is how we will calculate the present value of a perpetuity, right? Future value of a perpetuity is not calculatable because there is no ending future point in time. Okay, let's change color back to black and try to begin to solve some examples. So let's construct something. Let's say question 1. And I'm saying, assume that today's date is this, December 31, 2015. And you will need, so the moment you read this, you will need, your mind should immediately tell you that the talk is about future because you will need $1,000. When will you need? You will need this on December 31, 2019. And you also know that if you put some money into your bank today, the interest rate, the rate at which the money grows or compounds is 8%, and the rate is on a per annum basis, right? The question is, how much should you deposit today so that that deposit grows into 1,000 by this date? That is the question. So that you have a balance of $1,000 in your account on this date. Ladies and gents, can you identify, first of all, what type of cash flow pattern are we referring to here? There are only 3 possibilities: single sum, annuity, or a mixed stream. Which one is this type of cash flow? Which one is this?
Lump sum.
It's a lump. Yes, it's a lump sum. Yeah. Because you need to deposit a certain amount today, and that is all. You don't need to repeat anything. If nothing is being repeated, right, at regular intervals, it cannot be a stream of cash flows. If it cannot be a stream, it can neither be a mixed stream nor it can be an annuity. So it's a lump sum. And what do we have to compute actually? What is given to us? I'm seeing that there's a difference in time. This difference in time is what? From end of December 31, 2015 to end of December 2019. So I know N is equal to 4. I also know what are my time value variables. If you remember your calculator layout, it's always easier to just replicate it and see which item is missing from the information. Your calculator lays out your time value keys as follows. There's a key for N, there's a key for I over Y, interest per year, then you have a key for, I think it's present value, then you have a key for payment, and then you have a key for future value. So let's just put in what we know. We know N is 4. We know interest per year is 8. What do we know? Present value, we don't know. And since it is not a stream, there will be no payment, so that's 0. It's because it's a lump sum. In the future, that is after 4 years, I need an amount which I know is equal to 1,000. So I know what is the future amount I want. So only one thing is not known, present value. That has to be calculated. Now, it is your choice which method you want to employ to calculate the present value. Do you want to use the calculator? Do you want to use the formula? Do you want to use the time value table? It depends on you. So if we, for example, use the formula, we would say present value is equal to the future value times 1 over 1 plus R raised to the power N. So I will substitute the values for you. You can just calculate the result. 1,000 is the future value. I pick up from here, multiplied by 1 over 1 plus R. R is 8%. So I'm saying 1.08 raised to the power of time. Time is 4. So the result of this will give you the present value. This is the formula way. And if you are wanting to find out the same thing through the tables, you will say FV multiplied by present value interest factor of $1 at 8%, 8% for 4 time periods. And you will write your $1,000 here, and you will, from the table, look up this factor for 8% against 4 periods, read it and put it here, and that will give you the future value. If you want to use your calculator, well, you will provide inputs. This is correct. This is correct. This is correct. This future value, you need future value. This is the money that you need at this point in time, right? So you want this to be incoming. So this will go in as a positive number, for which you will have to deposit something today. Depositing something today means taking money out of your pocket and putting it in the bank. So this number will come up on your calculator when you calculate it as a negative number, signifying an outflow today, and then followed by an inflow tomorrow. So let me know what your answers are, please. Give yourself some practice. If somebody wants to use time value tables, you will tell me and I will put them on display. Or maybe if I have a provision to share a file
I
via
use
the
a
chat.
calculator.
Okay. Otherwise, I'm also seeing if I can share a file. No. Okay, what did I do with my screen? I pressed something and the whole thing went off. Okay, it came back, thankfully. Does anybody need time value tables, by the way?
Could you repeat the question, sir?
The question is on your display. That today is 31st of December and you anticipate that you will need in 4 years' time $1,000. So how much money should you put in your bank account today, which gives you an 8% interest on
So
every
is it
year?
$735.01?
Yes, I have 735.3, yeah, about 3 cents. That's okay.
Okay.
Depends on which
I
method
use
of
the
calculation.
formula. I use the formula.
Or use the formula. Okay.
Yeah, okay.
Okay. I'm also trying to find the file to share with you, the tables file, so that if anybody wants to use, they can. So look at it in the chat box. The TVM tables are there. You can download on your own machine and see. So the result that we have here for this whole thing is the present value will be approximately $735. On the calculator, it will come up as a negative sign, signifying a cash outflow from your pocket. 735.010302, whatever, approximate. Did everyone get it?
Yes, sir.
Okay. Okay, great. Let's go on to another example. Let's call it question 2. This is saying that assume that you purchase, so you purchase a 6-year, 8% savings certificate. And you purchase it for $1,000. And the question is the value of the certificate. What will be the value of the certificate when it matures at maturity? So what do you think this question is about? What type of cash flow is implied here? Type of cash flow is, there can be only three possibilities, either it's a single sum or a stream. And if it's a stream, then it can be either an annuity or a mixed stream. We are purchasing a savings certificate and we are paying $1,000 for it today. And that's all that's happening, right? So it's a lump sum or a single sum. And what are we supposed to compute? So let's just lay out N I over Y. What do we have next? PV, payment, and FV. What do we know? We know 6 years, N. Interest per year, we know 8. We know that we are making a purchase today of $1,000. So since that is done today, this is 1,000. And because we are purchasing, the money is leaving the pocket, minus 1,000. Since this is not an annuity or a mixed stream, there's no payment, 0. And so we need to figure out future value. So if you're using the calculator, you know which value to store in which key and get the result accordingly. Otherwise, somebody who's doing a manual computation is doing this. And the result that I have with me for this is approximately $1,586.87. Check yours against this number.
Yeah, I got it.
Okay, great. 1,586.87 approximately. Right. Ready? Can we go on to another question, please? We will create something else. Let's say you decide to begin saving towards purchasing a new car in 5 years' time. So the plan is save for 5 years to buy a car, right? And when you look at your financials, you think that you will be putting up $1,000 at the end of each year for the next 5 years in a savings account. And the savings account pays us something, I don't know, 6% per annum. And I'm writing the 2 additional words here, which we are not going to go into at the moment, but I want you to start taking an account of this terminology. I'm writing per annum, but I'm also writing with it compounded annually. So I've just introduced the terminology. We are not going into it at the moment. Right. So this is the plan to save for 5 years towards buying a car. And this is the implementation part of it. The question is, how much would you have accumulated in 5 years' time? How much would? So folks, please identify the type of cash flow involved. Type of cash flow. There are only 3 possibilities.
Annuity.
It's an annuity because you will be saving, you will be putting some amount of money at the end of each year into your account. So it's being repeated. 1,000 at the end of the first year, another 1,000 at the end of the second year, another 1,000 at the end of third year, and so on. So it is an annuity. And while you're telling me it's an annuity, what kind? Is it an ordinary one or an annuity due? An
Ordinary.
ordinary is correct, because in an ordinary annuity, the cash flow occurs always at the end of the time period. So the question says at the end of each year. So therefore, it's an ordinary annuity. So let us see. So we have our N, we have our interest per year, we have our PV, we have our payment, we have our FV. So what do we know? We know time is 5 years. We know interest rate is 6%. What else do we know? We know that we are going to make a payment or make a deposit of 1,000 at the end of each year for the next 5 years. So at the end of each year, $1,000 are going to leave our pocket. So minus 1,000 goes into the payment. Nothing goes into the PV because you're not depositing a lump sum only once. You are repeating that deposit of 1,000 5 times. So it's not as if it's a one-time event. So if it's not a one-time event, this is 0. So, and you can ask your calculator to compute the missing item, future value. And if somebody wants to do it the formula way, you will do it. You will carry out these steps on the scientific calculator. Either way, you should get the same result with the minor difference maybe. My result is this. I'll share that with you. If you did the formula way, then this will be this is my result for the problem. You can share yours. What did you get?
I got a
Okay. Anyone else is getting the same answers? Everyone? Anyone facing a problem? Can please interrupt and ask.
Same thing, sir.
Okay, Avalon, great. Okay then, folks, I'm changing color to red, and to this question, I'm making a change. Please incorporate that change in your answer. So I'm saying that we're depositing $1,000 at the start of each year instead of the end. So instead of end, we are saying at the beginning, or that's the start of the year, so that this is no longer an ordinary annuity, it becomes an annuity due. What additional change you need to make to arrive at the figure, the answer? Anybody can give me a result? Remember, if you're to calculate the future value of an annuity due, you do all of what we have done so far, and we multiply this result that we had gotten by 1 plus R. So it will be 5637.09 multiplied by an additional 1.06. When I do this, I obtain this result, 5975.3185. Is this okay with everybody? This additional term takes care of the annuity due. What do you realize? That with an annuity due, you were able to save more. Can anybody identify the reason for it? If you were depositing your $1,000 at the end of the year, you could accumulate $5,600 odd dollars. If you were depositing the same $1,000, but instead of the end, you deposited them at the beginning of the year, then you got about what, $400 extra. You ended up with 5,975. What might be the reason for this?
So would it be that you, as you deposit at the beginning of the year, you would have had that year interest
Yes,
before the end of the year?
exactly, Shivan, and that's the reason for that. When we have an annuity due, the deposits are happening at the start of the year, so your deposit starts earning interest right from that day, right from January 1, let's say. But if you started the deposit in the first year, all right, but on December 31st, so that whole year was gone anyway. It didn't earn any interest on for that year. So because the deposit came into the bank on the 31st of December, and no time was left for it to earn any interest whatsoever for that period of time. So with an annuity due, we always have an additional year's interest involved, and that increases the value of an annuity due. So this, you could remember this as a small result somewhere in your mind. Take a mental note of this, that the value of an annuity due will always be greater than that of an ordinary annuity. Yes. Let's proceed. Let's run out of pages. Let me add a couple more. Okay, so let's proceed to another one. Let's see what else we can do. It's just playing around, that's all. Time value of money, to me, it has always been fun. It answers
So
quite a
one
lot of
question, please.
practical questions. Yes, Maslin.
Explain. So how did you end up with the 597.5, the 300 and something dollars more? What did you do with the formula? I did
did
not pick up.
this. So let me write this in blue.
Thank you.
I found out the future value of the ordinary annuity, which is this amount, which I've already calculated. And I multiplied this by 1 plus the interest rate. That's what I did. Is
Thank
it
you.
okay, Maslin?
Yes, sir. I just taken a few minutes, sorry, 2 minutes.
Okay. Meanwhile, we can start creating another situation. Let me. Okay, let's create a situation of a loan. Let us say we apply for a mortgage loan. Let's go back to black. And the loan amount is 60,000. This is the amount of money that we want to borrow to maybe finance a new home. And the bank, let's keep it simple at this stage. The bank will require you to make, they will require you to repay the loan in installments, equal installments, on an annual basis, let's say. So annual payments that you will need to make to repay this loan are equal to $7,047.55 every year you need to repay. And you need to keep doing this for, so this is annual payment, and you need to keep doing this for 20 years. The question is, what is the rate of interest that you're paying on your mortgage loan? Determine the interest rate. Ladies and gentlemen, if I do not explain this or do not talk about this situation any further, will you be able to compute on your own? Or do you need me to keep talking? Would you want to give it a try solo? Or do you need
Nah,
my
keep
company?
talking,
That's
sir.
right.
Okay. So then what are the type of cash flows implied here, first of all? Type of cash flows. Well, we will be making annual payments. We will be repeating the same sum again and again and again. We'll keep doing that for 20 years, isn't it? So, and also the fact that we have taken a mortgage loan. When do you take a mortgage loan? You have taken a loan today, and in future you will make these payments. So just look at the situation as it is. This happens today, you take out a loan, and this happens in the future. It keeps on happening in the future till the loan is repaid. This is the future happening. So type of cash flow, this part is the present value. So it's a lump sum, right? But the annual payments are happening in the form of an annuity. And let us say these payments you are making at the end of each year. While we're at this, let me also tell you that unless otherwise specified in a question, if the question is silent about it, you must assume that it's an ordinary annuity where the payments are happening at the end of the time period. For something to be annuity due, where the payments are happening at the beginning of the period, the question needs to state that specifically. If it doesn't state anything, you just assume that it's an ordinary annuity. So for most of this question, we are dealing with an ordinary annuity. It is a situation similar to the timeline that we had drawn a little while ago. Remember, with a perpetuity, we had drawn a timeline, $1,000, $1,000, $1,000, and it just went on. Well, let's say it doesn't go on, it ends at time 20. So it's no longer a perpetuity, it's just an annuity now. Consider that these are your loan payments. At the end of every year paying thousand, and today you had borrowed at time 0, you had borrowed 60,000. So 60,000 borrowed today comes in, so therefore plus sign, and the payments that you have now, you're required to make now, which we can just write the actual ones. Seven, it's approximately 7,000, because I don't have a space enough. I'm just writing an approximation just to make a point. Where is my pen? So you are making payments because the money is leaving your pocket now, minus 7,000, minus 7,000, minus 7,000, minus 7,000, and so on till 20 years. This is the situation. So this is the annuity part of it. This is one lump sum part of it. Yes. So if this is the situation, the question is asking you, what is the interest rate implied in this? Because the bank would charge you interest, and on the basis of that, they would have determined that you need to repay every year about $7,000, right? So this is inclusive of interest. Every time you make an installment payment, you make some interest payment with it. So the question then becomes this. Let's just write down our calculator key format. We have N, we have I over Y, we have our present value, we have our payment, and we have our future value. So what is known? We have taken a loan today. We know that. So $60,000 we get into our account today. $60,000 we get into our account today. So plus 60,000. How long the loan is for? 20 years. Interest rate, we don't know. That has to be determined. Payment, we are making every year, 7,047, because this is being paid out. So negative sign. And it has no future value. It doesn't end. At the end of 20 years, we don't get or pay anything, because by the end of 20 years, the loan is settled and every party is okay, done with it. So this is 0. Please compute interest per year, ladies and gents.
We are 9.99.
9.99. Okay, so this is 9.99. So let's just round it off 10% per annum. Right. Why did this thing in medium? Okay, 10% per annum. Everyone got that? All of you who have the calculator. If you don't have a financial calculator and if you're thinking about doing a manual calculation, please note on your writing material as follows. When you're dealing with an annuity and you want to calculate the rate R or this IY, it will not be possible. It will stick you into a loop. You will keep going in circles and there will be no solution. It's indeterminate for the most part. So there are only two ways to solve for the rate of interest when dealing with an annuity, and that is either use a financial calculator or use time value tables. Manual computation will take you nowhere, right? So I'll put an asterisk here for that. Manual computation, M for manual, computation, not possible. So use financial calculator, yes. Use TVM tables, yes. So I don't know the situation of all the people who are attending the session today, 15 people out of 15, how many of you have calculators? I don't know. Does anyone want to try this out through the time value table way? I've shared the time value tables with you also. So the table that you will need to go to is the formula. Basically, if you wrote it in the formula format, you could write it as follows, that present value is equal to the payment multiplied by the PVIFA of R%, which is not known, and for number of time periods. So if we were to substitute, it would kind of look like this. Present value, we know 60,000. Payment, we know 7,047.55. And PVIFA, we don't know as yet. PVIFA of R% is not known for N time periods. N time periods, how many time periods are there? 20. So what we can do if you're solving it this way is you can write it as this. So we'll isolate the interest factor alone. And if you will divide this, you will get something close to 8.5. % for 20 periods. Now what we can do is we can go to the table. But this time, note the fact that we know the value of the interest factor already. We know which period we are interested in. We have to read out the value for the interest rate, right? So let's go to the table and see. Present value interest factor of an annuity of $1. So this is that table. So let me pull up the annotation tool so that everyone can see. So what was the factor that we obtained? We obtained 8.5136. And let's put the whole table up, right? So we know 20 time periods. So we are interested in this row. So in this row, these are the interest factors spread out through the row. I'm going to read a factor which comes closest to 8.5136. See, I'm seeing exactly 8.5136 here. So this is the interest factor that we calculated earlier. And against this, if I read the interest rate, so this is 10% here, right? So this is my answer, 10%. So if you were using tables, you would calculate the interest factor which would be 8.5136. And in the row for 20 periods, for this factor, you will read the corresponding interest rate. That will give you your answer. We are okay with this, ladies and gentlemen. Any questions?
Yes, sir. Okay.
Okay, cool. Okay, let's continue with this question then. Let's change it a little bit. What number did we give to this? 4. So let's call it 4A maybe. So this R% we read from the table was 10%, right? So that's the answer. So question 4A, and most likely this would be the last thing that we will be able to do for today. I'm just trying to create a variation because I want to tell you that loans like these, whenever we go to a financial institution asking for financial assistance in the form of a loan, be it an education loan or home improvement or just a consumer loan or maybe a mortgage loan or vehicle loan, whatever, what they do is that they ask us to pay it back in installments, just like we've seen. So this feature, which allows you to pay back a loan in equal installments over time. So let me just erase this because I will need to write a term first. The feature or the characteristic of a loan which allows you to repay it via equal periodic installments over time is known as amortization. Remember the term amortization. It simply means periodic repayment of the loan through equal installments over time, right? So when we are paying $7,047.55 now, in this case, every year, we are paying it off bit by bit, bit by bit, bit by bit. In other words, we are simply amortizing the loan, right? So on the basis of this understanding now, we can create a related question. Question 4A. All data from question 4 applies. So it's a 20-year loan. And the loan amount is $60,000. The installment amount, is $7,047.55. Interest rate we have calculated 10%. What we want to do is to prepare a loan amortization schedule. And to prepare a 20-year schedule will take a long time. We will just restrict ourselves to the first couple of years. Loan amortization schedule. Basically, loan amortization schedule is a table which tells you that every year how much do you pay, and out of whatever you pay each year, how much of the principal amount have you repaid and what part of the repayment went towards the payment of interest. And it also tells you that when you're done making the payment for a given year, how much of the principal amount remains outstanding as you enter the next year, right? So all that detail is visually available to us in a table. So when we fill out the various cells, rows and columns of the table, we get to know the information at a glance. And such a table is known as a loan amortization schedule. So the question based on the loan amortization schedule, we will prepare one shortly, is that how much of the principal was paid in the second year of this loan. So let's write down the question. And when we prepare the schedule, we will read off from the schedule this item. How much principal amount was paid in the second year. Right. So let me first give you a template for this. So if you are using writing material to do your own computations, create a table like this where The first column you can dedicate to writing the years. Second column, you can write payment. Third column, you can write, or we can do what we can, to make it more visually easier to understand. Let us give this thing a broad heading, payment. And we can divide the payment into two parts. One part is towards the payment of interest. The other part is to the repayment of principal. Repayment of principal. And then we can write a column for outstanding balance, remaining balance. So if we were to create something like this, right. So here we would keep writing our years. So we would write year 1, 2, 3, 4, and go up to 20. We don't need to do that because that's going to take us an awfully long amount of time. We will restrict ourselves to the first 2 years. So in the first year, we make a payment of $7,047, right? Every year we are making this payment. And so let's highlight, this is the payment. Now this payment is divided into two parts. A part of this payment goes towards interest payment, and another part goes towards the repayment of principal. That is how amortization works. So we need to figure out how much of the $7,047 we have paid in the form of interest in the first year. So the interest rate we had calculated is 10%, right? So which means at the top of the first year, this is the outstanding balance because this much loan we have taken, 60,000, and the interest rate is 10%. So 10% of 60,000 is $6,000 interest. So out of $7,047.55, if $6,000 are paid in the form of interest, that means only by the end of 1 year, you have paid principal worth $1,047.55 only. So you see, in the initial years, you will observe if you will keep populating this table, you will realize that in the initial years, first 5, 6, 7 years, most of what you are repaying to the bank is applied towards interest. The bank is particular about getting their interest quickly, and very less of what you pay is applied towards the principal repayment. So after 10 years also, you will realize, oh, I've been paying for so long and still so much balance remains outstanding because very less of your installment amount is being applied towards principal repayment. So for example, at the end of the first year, how much money you will still owe the bank? You had borrowed $60,000, you have repaid only $1,047.55. So if you take a difference of this 60,000 minus 1,047.55, it will give you 58,952 and a few cents, like 45, 46 dollars. Right. So in spite of the fact now that you have paid $7,047 to the bank, the principal has dropped by just about this amount, right? About $1,000 or so. Most of the money has been applied towards paying interest. Now, second year. In the second year, you enter this year with this outstanding balance, 58,952. So now the payment for this year is again $7,047.55. Interest rate is 10%. 10% of what? 10% of your outstanding balance, which now is this. So you will calculate 10% of 58,952, which will be somewhere $5,895 and some cents, right? And if $5,895 are applied towards the repayment of interest, only the difference between this amount, 7,047, and this amount is applied towards the payment of principal. So 7,047.55 minus 5,895, which will give you around some 1,152 or $53. This will be applied towards the repayment of principal. And then what will be your remaining balance outstanding? So the last balance outstanding was 58,952 minus this much has been repaid. So 57,800 or something will remain outstanding. Like that, we will proceed 3 years, 4 years, 5 years, and go on to complete all 20 years. What you will see is that as you go ahead in time, the repayment of interest, the interest column will keep falling gradually, gradually. And the repayment of principal column will keep on rising gradually. So as you move ahead in time, more and more of your principal will be repaid, and less and less of the payment will be applied towards interest. But in the initial years, the bank will make sure that they have earned all of the interest that they want to earn, because remember, a dollar received is more valuable today than it is tomorrow. So they want to receive all of their interest today and maybe reinvest it. Meanwhile, I see a message in the chat. Dolores, yes, it's depressing, but it's the reality. And the time value of money, learning about it makes you aware of that reality. And knowing about it is power, right? So when you go to negotiate a loan next time around, negotiate for as less a time period as possible. So if you want to stretch the loan, a 20-year loans to 30 years, it will become that much more costly because you'll be ending up paying more interest. So
So
if you
excuse,
can,
please, one
yes,
question, just to cut you across, keep what you had to say in mind. This 10% interest, is it taken off of the remaining balance of the 58,952, the 57,800 goes along as the years decrease?
that's right. So in third
Oh.
year, the interest will be 10% of this.
Of 57,800.
Yeah,
Thank you.
right. Ladies and gentlemen, the time is run out, but if you can spare about 5 more minutes, I can tell you how to do this thing on the financial calculators also. Would you like to do that?
Yes, sir.
Yes,
Thank you.
sir. Thank you.
Yeah,
Okay.
hang on.
All right, so we will keep the calculator as well as the writing pad on display. We'll try to have a visual of both at the same time. Okay. So if you have a problem like this at hand, and if you are to prepare an amortization schedule, what you should do is, let's first of all make sure that we have our time value of money memory clear. Second, function clear TVM, right? And clear the display as well. In this question, we know that the amount of payment that we have to make each year is $7,047. But if you want to do this stuff on the financial calculator, you must calculate this yearly payment or periodic payment first on the calculator. Without doing that, we cannot proceed on the calculator. So what I mean to say is that if you go back to the previous question, no, we didn't do that because we assumed the payment in question 4 and 4A both. So let's assume the question to be this, that this is a 20-year loan, which has to be repaid back in 20 annual installments, and the rate of interest applicable to the loan is 10%. So with that information, we will proceed. Let's first write down this information here in the format that we want to. We have our N, we have our I over Y, we have our present value, we have our payment, we have the future value. So we want to repay the loan in 20 years' time. The interest rate that the loan carries is 10%. The loan that we have taken today is $60,000. And there is no future value because by the time we reach 20th year, everything would have been paid up. 0. So we have to calculate the payment. My point is that if you want to use the financial calculator to prepare a schedule like this, then it cannot be done until and unless you provide these inputs first and calculate the payment, right? So payment must be calculated. It must not just be entered into the calculator. It must be a result of a calculation. So provide these inputs to the calculator, please, and compute the payment on your device. I will do it here as well. So I'm saying here 20 is my N, 10 is the interest per year, $60,000, $60,000 plus is my present value. Future value is 0, so I'll just leave that out and I'll say compute payment, which gives me this figure, $7,047 and about 57 cents. So you see there's a minor difference. On the writing pad, we have written $7,047 and 55 cents. So if you do it on a calculator and when you use a time value table or when you use a scientific calculator using a formula, these minor differences will be there, rounding off errors. So don't be bothered by them. So this is our payment, and as expected, you see that the payment has popped up as a negative number, indicating that this money is leaving our pocket as we are paying this amount. Now, do not clear your time value memory, please, right? Don't clear the time value memory because this payment that has been now computed on the calculator must stay in the calculator memory for us to proceed to the next step. The next step is, please follow my voice prompt and the cursor movement on the screen. You press the second function and you press this button. You see at the top of it is written amort. So it's going to take us into the amortization. So press this amort. Now in the display, you should see is P1 is equal to some value is written there. So let's just look at the format of this thing. So we will be using the scrolling keys. P1 means the start of the period. And if I scroll down using this scrolling arrow, I will see P2. This tells me the end of the period, right? And then, so this total thing means that I'm concerned with the period which starts at time period number 2 and ends at the end of time period 2. So basically, this is talking about the second year, right? So my time starts at second time period and ends at second time period. And so within this second time period, at the end of the second time period, what will be my balance remaining? It's giving me a readout, $57,800, which you can relate to this number here. This number here on the table, you see where my cursor is, 57,800. So you can prepare a table template like this and keep computing on the calculator and keep filling up the table. So if you scroll down further, you will see that during the second year, $1,152 of principal was repaid. And that is what we had written in the table as well earlier against second year. If you scroll down, you will see an interest payment of $5,895 and a few cents was made in the second year. So you can read it out of the calculator display and keep populating the table like that. If you scroll down again, it will come back to P1. So it's a circular thing. So you'll start from P1, then go to P2, then go to balance readout, then go to interest readout, principal readout, and then come back again to P1, right? So now, let's say we have completed the row for the second year, but the first year is still not filled. So we will start our definition P1. Let the period start from time period 1. So I'm pressing 1 and I'm pressing enter. And then I'm scrolling and I'm saying end my period at the end of time 1, not at the end of time 2. So I'm pressing 1 and pressing enter. So I can scroll back up to confirm. My period definition starts from 1 and ends at 1. So within the first time period, what all is happening, I can then begin to scroll and to find out. I can scroll and read out the balance remaining after the end of 1 year, 58,952. That's what we had written earlier in the table. We can scroll and read out the principal repaid, $1,047.55. That's what we had written earlier. Interest, 6,000. That's what we had written earlier. Scroll and you come back to P1 again, and you can then start working for another period. So let's say if we were to work for third period, we will say my period starts from the top of the third period. Enter, right? And then scroll. And if I forget this and I scroll down, it's absurd, because how can I start the third period and end at the first period? It's not going to be possible. So it will say error, right? So I'll go back up and fix the error. So I will say second, so let me clear, second amort, and P1 is 3, so P2 is also 3. Enter. And then I can take my readouts. So I can, once I have this readout, I can begin to fill the third row here. I'm not doing it because if I place my cursor, my pen on the writing pad, the calculator would go away from display. So I'm not doing that deliberately. But once you have the balance readout, you can fill the amount 56,532 in the last column here. Here, in this column, at the end of year 3, this much would be the balance remaining, 56,532. Then you can scroll and read out other values and fill them accordingly. Principal repaid would be 1,267 in the third year. Interest paid would be 5,780 at the end in the third year, and so on. And you will come back to P1. You can change the value again for the fourth time period and go on doing it do this for 20 times, and your table would be ready. So this will give you the entire loan amortization schedule like this, right? Once you're done with this, you can clear your display, and then don't forget, second function, clear time value of money, so that everything is going back to 0 and you're ready for a fresh calculation. Ladies and gentlemen, this is how far I wanted to go today. If there are any questions, you can please ask. And I'm again urging, please start reading and practicing the questions, because if you postpone for too long, it will build up very, very quickly. So please don't postpone any longer. Please pay attention to all your readings and practice questions. Anything that you would like to say before we depart for today? You're welcome, Dolores. Anything that you would like to say, add, ask before we close? All right, no comments, no questions. Yes, Avalon?
Thanks. No comment.
Okay, then. All right. Right. So then take care, everybody. We
Thank you,
will
sir.
meet
Bye-bye,
again.
everyone. Thank you, sir.
Yes.
Yeah,
Bye-bye then. Take care. We'll meet next week again then. Bye.
Bye, sir.